What was that Apollo mission code? There is a famous photo of Margaret Hamilton standing next to a pile of code that was printed out on a large stack for Apollo 11's mission guidance systems, which launched in 1969. This code is fascinating for a number of reasons. The code was written in a time when boundaries were being pushed very quickly, both socially within the USA and technically. Humans writing the code would leave traces of this humanity within the code itself. To all intents and purposes, it was assembly, just not the x86 or x64 Intel assembly that we usually see these days, as this was specific to the Apollo Guidance Computer, or AGC, which you can see in the source code. Apollo's code was split into modules. For instance, Comanche was the command module, which was later replaced by Colossus, and Luminary was the lunar module. Inside the Luminary module code is a file called burn baby burn master ignition routine.agc. In the header notes of this file, it tells us of the get-together of the AGC developers celebrating the 40th anniversary of the first moonwalk, where Don Eales, who was one of the authors of this routine along with Peter Adler, related a little story behind the naming of this routine. It traces back to 1965 and the Los Angeles riots, and was inspired by disc jockey extraordinaire and radio station owner Magnificent Montague. Magnificent Montague used the phrase "burn baby burn" whenever spinning the hottest new records. Magnificent Montague was the charismatic voice of soul music in Chicago, New York and Los Angeles from the mid-1950s to the mid-1960s, and this pop culture seeped into the Apollo mission code. Despite the fun side of this code, there was a very real prospect that if there was anything wrong in these routines, astronauts would simply perish. What makes this even more amazing is the method in which it was done. The computer which ran this code was not powerful by today's standards, though it was specialised to the task of controlling the engines. It was built by Raytheon and used just 55 watts of power. It had a 2 MHz RTL or resistor transistor logic based processor using resistors as the input network and bipolar junction transistors or BTJs as the switching devices. It had 16-bit word memory with 1 bit used for parity. RAM was 2048 words. And there was 36,864 words for ROM, or about 72k. Which compared to an 8GB Samsung Galaxy S10 means the Samsung has over 111,000 times more storage. It weighed in at 70 pounds, the reasons for which will become apparent in a minute when we have to cover how the ROM was made. The computer was communicated with using a numeric keyboard and display, called a DISCI, which is short for display and keyboard. Where things get really ropey in a literal sense is the ROM, where most of the code resided. This ROM had to be reliable in an environment where it didn't fully understand how space might affect it, so you had a lot of that 70 pound of computer in this nearly indestructible ROM that they used, which had previously proven itself in the Mariner probe missions to Mars starting in 1962. After the programmers had written out cards with their instructions, it was transcribed by others to hole punch. That's the next place where errors or mistakes could have crept into the process. The cards were then fed into a simulator to test them. If everything looked okay, the binary version of this code, or the actual machine code, was then sent to a team of sewing ladies. This led to the term LOL memory, meaning little old lady memory. The seamstresses and sewing ladies would then manually build the ROM as core rope memory. This basically means that dense reliable memory that you can measure in cubic feet of ROM could be made. Without getting into the technicalities of pulsing the rope and reading the corresponding values, the basic premise is that the way that each core is wound by the wires will determine if that core or bit is a 1 or a 0. Again, everything had to be checked to make sure no errors crept into the process, which could accidentally send the astronauts to their doom. A variant of this memory, called plated wire memory, is still running in the Voyager 1 and Voyager 2 probes, being used in the CCS or computer command system at the extreme edges of the solar system as they head towards interstellar space, and the only reason that they'll stop being read is when the nuclear fuel runs out in the coming years. A number of years ago, the Apollo 11 AGC code was released on GitHub so that anyone can look over it. If you are a programmer who is familiar with the assembly programming, it is worth a look over. I hope you found this video interesting. If you did, please give it a thumbs up. Otherwise, give it a thumbs down. If you want to see more, please hit subscribe. Cheers.